watching some Star Wars Clone Wars. Well, Rebel or whatever. Bad Batch. This one I honestly don't remember because I did this last time I took the class. Some of these ones anyways. Yeah, gonna have to look at that. These are all have to do with conservation of energy and momentum. Anyways. Oh, yeah. Down. Already done. These are where I started. So you just, this is your, oops, I reference it somewhere. I have no idea. Yeah. T1 plus U, 1 to 2, and T2. This is my T1, U to 2, and T2. So this is the force that I'm trying to solve for. This is the amount of force pushing down from gravity. This is over the amount of time. This is our initial velocity times our mass, which is this. That's the conservation of. Anyways, these are reduced into forces because that's a component force there. Yeah, that really doesn't make sense. I've got to really look through this chapter again because this seems more conservation of energy. This must be conservation of momentum. Because this would be conservation of energy. Mass times velocity squared. Why is this not mass times velocity squared? I don't know. That's actually confusing me right now. Whatever. Time is 3 seconds. Solutions manual did this different, but I figured, well, if our acceleration is constant, well, our force anyways, over the duration, then I'd get the same answer, and I did. So do it the same way. Mass times velocity plus my force over my duration of time equals my mass times my velocity. This one we flip it. This reduces to 0, and in this one, this goes to 0. And on this side, we're combating gravity, and this side, we're combating the tension. So we get a system of equations to solve for our time. We make those cancel, and then we can come back here and put the time in, get our tension. This one's the most useful information one. Bullet, blah, blah, blah. So this is our formula. This is really our formula. So this one's 1/2 mv squared. And this is essentially 1/2, well, it's not 1/2 mv squared, but it tells you your amount of energy in that direction. Or am I thinking wrong? Anyways, force equals 1/2 mv squared. Or mass times acceleration, which is what this is, mass times my gravity. In that component of the length. So that gives us our component. Of our force. Well, it would be down, so yeah, 1/2 v squared, since these are all the same, goes to that, and then you can square root that, and you get 4.646 V naught. You get I did this wrong first. I did it over 1, which I realized was wrong. 778. Then you times your then you put it back in a similar formula again to what you have on the top. Really tired. It's 2 in the morning. Can't think straight. This one I didn't do. This is the last one I just did. You get 0.05437. Your height is 0.2936. You set this up where the conservation momentum, or whatever you want to call it. You take this is really set up E equals this over this or whatever. But you can use that to set up a system of equations because you've got this one, which you found, and then you've got, am I pointing to the right one? That's not the right one, this one. Then you compare them side by side. This is where I didn't understand. When I'd get this, I checked the solutions manual and online solutions manual, and they both have it the same way, which is not the way I was getting it. They got 2.4 meters per second and then 0.8. Well, if you do it based off of this, VA prime equals 4 minus your VB. Well, your VB equals VA prime minus 1.6. So 4 minus VA prime minus 1.6 is, well, that's 2.4, but you add this over here. That should be 2 VA prime equals 2.4. And so that would be 1.2, and that gives you negative 0.4 over here. So I don't know what they were doing because the solutions manual, both of them have it wrong according to what I'm thinking. So I don't know what's going on there. Anyways, MA's on both sides of this. Just take away, give you a height. Really, I'm gonna need to go over all these again because I'm not thinking right now. 1/2 MA. It's my T1, TV, blah blah blah. That's just for down here. This is for down here. What? Oh, that's not for down here. That's a different 2.88 MA and 0.32 MB. Oh yeah. That's how tired I am. I didn't notice MA versus MB. MBX is 0.05. Cancel those out. The MBs. Your distance is 0.05437 meters if this is accurate. And it actually goes to the left. Well, this just whole question set up as if it went to the left, so I'm probably not right in saying that this is a negative velocity. Okay, so I use this over here. This whole little doodad. Then this one's used for this doodad. What I didn't show here is that this is like a T1 plus my U equals my T2. My T2 What's going on? I can't think right now. Whatever. That's our last number.